Students, let's look at this question, which is on inequalities taken from the year 2019 NJC block test. Question 3. Using graphical method, solve this inequality. I think this is pretty okay. What we need to understand is usually in modulus form, what I will say is just use GC to solve it. Okay. So in this case there, they didn't ask us to find the exact point, but if we want to find, then we need to break it down. But this case there, I think breaking it down will be quite difficult to find that. I mean, not difficult, but it's very tedious. So this, just remember modulus, we have got either this will be plus or it will become a minus over here. Okay, whereas for the second modulus here, okay, the second modulus here, what happens is this would be either plus or minus as well. Okay, so there are two outcome that we will get. Okay, so that's the main thing here. So in other words, this middle expression, we have like 2 times 2 permutation wise, we got 4 equations. We need potentially 4 equations. Okay, but in this case, because they didn't ask for exact, so we can just use GC and solve it. So just bring our GC and sketch and see what this expression, this graphical method here, how it looks like. So from GC, just go to the graph there. Then what I'm gonna do is just gonna put in this as my y1. Okay, I want it to be in between -3 and 3. So this case, what I'm gonna do is just where you go math, just go math, then you just go to absolute value, then you just key in x squared -1. Then this is minus of math, absolute value as well. Then it goes to x plus 3. Just key that in. So once you get it, it will be this graph here. Obviously, what we need is actually in between here. So what I'm going to do is actually going to draw the line -3 and 3 here. Okay. Then I use the dotted line because it seems like more neat. So I'm going to zoom box here to where there are a lot of wasted white space around. So I don't really, I think it's good to utilize your GC. Then we're going to copy this graph in. Okay, so from this graph here, what we need is actually just to, because we weren't asked for the exact, so we could just find the intersection here, and we could just find the intersection here. Okay, and we could just go to find the intersection here. Okay, we want all the x value which is between negative, so the curve here, we want it to be this y1 between -3, this is y equals to 3, and -3 and 3. So the value which would give us between -3 and 3 would be this curve here, which is between -3 and 3, and this also, so meaning to say we need to find this as well. Okay, so this case here, just draw the curve here. Okay, anything, the highlighted yellow part of the curve will be basically the part where it's between -3 and 3. So what I do is you just go to GC and just find the intersection point. So calculate number 5, intersect. Then you just intersect, just slowly go to the other side. So here, enter. Then scroll up to the green line, enter. That will be -2.1925. So this is, I'm just going to find this is negative 2.19258. Okay, then the next one would be, we just try and find the intersection here. So second, calculate intersect again, go to the other side, then press enter. You select the blue line just by scrolling up and down. Okay, scrolling down, press enter. That'll be negative 0.618. 0.61803. Then after which we need this intersection point here. So I'm going to calculate the intersection point as well. Here. Then that'll be 1.618. Okay. Then of course, then this will be 0. Then after which we just intersect again. Then select the green line. 3.1925. 3.1925. Okay, so from the graph, from graph, solution, right? So x is between, they do not need to be equal, so meaning to say minus 2.19 between x to, because these are the region, right? Between it, not equals to here. Let me just draw it out. The solution will be here to here, then I'll reach here to here. And write it down. 0.618 or 1.62 x 3.19. Okay, so that's how you do the first part there. Not an issue, I feel. Should be fine. So let's look at the second part. Without using a calculator, find this inequality. I think that's pretty okay. There's quite a standard inequality question there. Without using, meaning to say we're just gonna move the 1 over. Cannot cross multiply. I think the main thing is to remember not to cross multiply the x plus 1 over, okay? Because x plus 1 could be positive or negative. So in this case here, at most equals to 1. At most 1. So bring the 1 over. Shouldn't be an issue. Then make it a mo 0. Then x squared plus 1 minus x plus 1 over x plus 1. mo 0. Then from here, we'll get this x squared minus x. Oh, wow. Okay, great. Then this will be x minus 1, x plus 1, mo 0. Okay, we could just use test point method here. It's okay. Just 1 here. Just draw down all the roots here. So you have 0, then you have 1, then you have x minus 1, right? So the roots 0 and 1. So remember, there's a vertical asymptote across here. So you just leave it here. Okay, that is the case here. So you put a super huge value here, super huge. So but there's no repeated root here, so everything will just alternate. Okay, so you just put x1 million, this is positive, x1 million in this region that we're testing. Okay, so if this is positive, then this 1 million minus 1 is also positive value. 1 million plus 1 is positive. So overall this is positive. So if this is positive, what we need next is essentially just, oh sorry, I copied okay, the question is typed wrongly, sorry. It's 3. So let me just rearrange everything. So I just retype everything. This is 3. Sorry, typed wrongly. Then once done, this case here will be x squared minus x minus 2. So we could easily factorize it as well. So this is x minus 2, x plus 1. Alright, so this is x plus 3 at most 0. Same thing, test point method. List out all the roots on this what do you call it, this reciprocal. This is 2 minus 1 minus 3. So minus 3 is here, negative 1. Okay, now take note, the negative 3 here, this is the vertical asymptote, so it cannot equal to the root there. So we're going to test a super huge value, like essentially like 1 million. So if this is 1 million, this is positive. This is also positive. Then this is positive. If it's x is 1 million, so this is positive. There's no repeated root, so you just alternate plus, minus, plus, and minus. Once this is done, we need this to be at most 0, less than 0. So this one here, and this region here. Okay, so hence, do you want a solution set or just without you solve the inequality? So x less than 3 or okay. So that's how we do this question here proficiently. If you have any questions at all, please let us know and I'll see you in the next question.